Hey guys, so today we're going to talk about 10.2, area of trapezoid, rhombuses, and kites. Sometimes you'll see rhombuses as rhombi, so just as a reminder about that. So, trapezoids. Remember, this is a quadrilateral with one set of opposite sides that are parallel. Those two parallel sides are always going to be your bases. You'll see them labeled as B sub 1 and B sub 2 in the formula. And the distance between those bases, which is always a perpendicular distance, see how we go from one vertex of base 1 down to the side of base 2 at a right angle. That lets us know it's the height. As a reminder, sometimes you might have a trapezoid that might have two right angles right here. And so then this would be the height and these would be your bases. So just a couple things to think about. One of the things that we do like to do on these kinds of questions is a lot of times we can make this triangle right here into either a 30-60-90 or a 45-45-90 triangle. And so sometimes I'll give you the hypotenuse and expect you to use that to help you find the height. So just wanted to put that out at the beginning. So our area formula for a trapezoid is 1/2 the quantity base 1 plus base 2 times the height. One of the things I do want to let you know as well, sometimes that height is put between the 1/2 and the sum of base 1 and base 2. It doesn't matter as long as you, in the end, multiply by everything in the list. So sometimes on the check, you guys will see it written as 1/2 height times base 1 plus base 2. Other times it's written with the H at the end. It just depends on who typed up the formula for that. So no, both of those are equivalent. So if we look at the state of Nevada, for example, number 1, Nevada is approximately the shape of a trapezoid. Obviously, we've got a couple of spots that you can see within the outline of my trapezoid that are not the yellow section. So it's not perfect, which is why we're talking about an approximate value. So if I look at this, I see that we have this distance is 205. This one is 511. And this other distance is 309. Each of these are miles. And so my bases are going to be the two that do not intersect. It doesn't matter which one's base 1 and base 2. And then my height is that distance between them. And so we'll set up our formula, 1/2 base 1 plus base 2 times the height. So area equals 1/2 205 plus 511, and then times the height of 309. You can type this all on your calculator at once, or you can use your order of operations to do the addition inside the parentheses first, which I think I'm going to do right here just to kind of simplify what I have to type in my calculator. So if we do 205 plus 511, that's 716. So then I'll take 1/2 of 716 times 309 and get an approximate area of 110,622 miles squared. So that's what a trapezoid would look like if we are giving you the bases and the height. Make sure you guys read the directions. Sometimes we also throw the height in that part because it's not always easy to add that to a picture, depending on your computer literacy levels. So the other thing we're going to talk about are rhombi and kites. I do want to remind you guys of two things that are kind of important here. So in a rhombus, the diagonals are perpendicular bisectors of each other. And so on this blue diagonal one, we know that this segment right here and this segment right here are congruent, and there's a right angle here. We also know then on the red segment D2 that this segment and this segment are congruent. Sometimes we have you guys use the Pythagorean theorem to find those measurements. Like maybe I'll give you the hypotenuse and one of the diagonals, and I'll expect you to remember these things from Geometry 1 in Unit 6. In a kite, the shorter diagonal is bisected by the longer diagonal. Remember, that's because that longer diagonal is a line of symmetry. And so it cuts this diagonal, which in this case, D1 is our shorter one, in half. The diagonals are also perpendicular, so sometimes I'll have you do the Pythagorean theorem, but usually not. Most of the time with these, you just have to remember that that shorter diagonal needs to be doubled, and then you'll need to just add together the parts of the diagonals. So, for example number 2, it says find the area of each kite or rhombus. So for number 2, we're given that this segment right here is 3 feet. And so if we know that that segment's 3 feet, then we know that this segment is 3 feet, making this diagonal, I'll just call it D1, 3 plus 3, which is 6. We are then also told that this section is 5 feet. And so we know that diagonal is bisected, so this is also 5 feet. Making this diagonal, since I called the other one D1, I'll call this D2, 5 plus 5, which is 10. So then our area is 1/2 diagonal 1 times diagonal 2. So 1/2 of 6 times 10. And so our area for number 2 would be 60, half of 60 is 30. So 30 feet squared. Yes, Athena, you want to be part of the video too? So for number 3, I see this one has 2 different length sides. So this is a kite. And so I want to look at the diagonals. I see that this chunk right here is 10, and this chunk right here is 20. So that diagonal, I'll call it D1, is 10 plus 20. So D1 is 30 meters. And then the other diagonal was nicely labeled for us. This is 10, and this is 10. So you can see that shorter diagonal is bisected. So then to get this diagonal, I'll call it D2. 10 plus 10 is 20 meters. Okay, I've got my diagonals. So now I need my formula. Area equals 1/2 diagonal 1 times diagonal 2. I always write them down again just to make sure I get all of the pieces of information. These are supposed to be pretty straightforward, but you want to make sure that you're not making careless mistakes as you go. So area equals 1/2. Our diagonal 1 was 30. Our diagonal 2 is 20. 30 times 20, I'm pretty sure is 600. Yep. Divided by 2 would be 300. So our area is 300 meters squared. Okay, so more examples. So for number 1, it says find the exact area of the right trapezoid PQRS. So we're seeing the words exact, and so because of that, we're going to want to make sure that we think about simplifying everything and then not like multiplying by square roots, or if we use trig, we would leave the tangent or the sine or the cosine inside of our answer. To keep it exact. So the first thing I kind of see on this is that we already have our bases. They're 5 and 7. So if I'm being a little bit, if I just want to start filling in the things I know and then start thinking about what I need to find, maybe that will be helpful here. So we got our bases, so area equals 1/2 of 5 plus 7. And then we're currently missing the height, so I'm going to draw that in real quick. And so when I do that, I notice over here on the left, I've got a 60-degree angle with a right angle. And so we've got our 30, 60, 90 triangle. So over here, I'm going to just remind us what all are the properties of a 30, 60, 90 triangle. So the short leg is our measurement that we'll need the most. It's what the other sides are based off of. Our short leg times 2 is the hypotenuse, which in this case wouldn't be the height of this triangle. So I don't really want that. And then the long leg, which is opposite the 60-degree angle, is the short leg times the square root of 3. And that's going to be what's most useful here since we need the height, which is the long leg. But I need a measurement. Well, I now notice that there's this cute little rectangle over here on the right. So that means that this chunk right here would be 5, and 7 minus 5 is 2. So that would mean that my short leg is 2. Which would then make my hypotenuse 2 times the square root of 3. Not my hypotenuse, sorry, the height. Sorry, H threw me off. So the height would be 2 square roots of 3. So then we'll plug that into our formula. And so that square root of 3 is what is going to, it's going to be the most useful here for our exact area. So I'm going to simplify this addition first, just because I've noticed a lot of people tend to accidentally multiply there. So 5 plus 7 is 12. And then 2 square roots of 3. And so then we'll take 1/2 times 12 times 2. And then we'll have that square root of 3 at the end. I sometimes like to write the square root of 3 right away, just so I don't forget it. That's something that I've noticed people doing on this unit. At least in my Geometry 1-2 class, and so I wanted to throw that out there as something to watch out for. So 1/2 times 12 times 2 is 12. So this would be 12 square roots of 3 meters squared. Okay. So for the next one, it says find the exact area of the right trapezoid. So we've got trapezoid, so area equals 1/2. The sum of my two bases times the height. So I'm looking right now and I'm like, okay, I see one of the bases is 14. So I can plug that in. But I don't know the other base and I'm missing the height. So I'm going to draw in a height right here. And when I do that, that reveals this 30, 60, 90 triangle. Now this one's rotated a bit differently, so I just want to double check and make sure I've got the right measurements in places. Also, does this angle look like it's 60 degrees? Probably not. So just know that this picture is definitely not to scale, because this is our 30-degree angle. So then that makes this side over here my short leg, and this is my long leg. So we're given the hypotenuse. So to go to the short leg, we divide by 2 because we're going backwards from the hypotenuse. So 12 divided by 2 is 6. So that means that this yellow section right here is 6. And so if that's 6, well, 14 minus 6 is 8. So that means that this chunk right here is 8, which I can then notice my rectangle I have there and copy that 8 over there. So I now have the other base, so I'm going to plug that in now. And we're still missing the height. So the height is our long leg, so we take our short leg and we multiply it by the square root of 3. So 6 times the square root of 3 is 6 square roots of 3, which will be our height. Let's make that look more like a 3. Okay, so area equals 1/2. I'm going to add 14 and 8. That's 22 times 6 square roots of 3. So 1/2 of 22 times 6. So I want to multiply everything that's not the square root of 3 together. And so that's 66 square roots of 3 centimeters squared for our area. Okay, let's look at some kites and trapezoids, not kites and trapezoids, kites and rhombi now. So for number 3, we want to find the exact area of the kite and the rhombus. We're given that that side length is 8 and that diagonal is 10. So what I want to do real quick is I'm going to draw in the other diagonal. I remember that this is a right angle because they're perpendicular bisectors. If this whole diagonal is 10, each of these is congruent, so this is 5 and 5. So then I'm missing this part and this part, which will be congruent. And so I can now look at my cute little right triangle, and I'm going to use that to solve for that other diagonal. So when I do that, I'm going to do x squared plus 5 squared equals 8 squared. So x squared plus 25 equals 64. 64 minus 25 is 39. And then to undo a square, we square root. And I want to figure out if this square root is going to simplify. So I'm like, well, 39 divides by 3 and 13. Both of those are prime numbers. So I'm just going to leave that as the square root of 39. So obviously this one's not super pretty and clean, but we can keep carrying on with it. And so then that diagonal that those are on is going to be the square root of 39 plus the square root of 39 as that diagonal. So it'll be 2 square roots of 39. And then our other diagonal is 10. So then area equals 1/2 diagonal 1 times diagonal 2. So area equals 1/2 of 10 times 2 square roots of 39. And so 1/2 times 10 times 2. So our area would be 10 square roots of 39 inches squared. And that one's definitely way messier. Usually I like to make this a Pythagorean triple, but it looks like either A, I forgot to change that 8 to a 4, not a 4. It wouldn't need to be the 5, wouldn't need to be there. But anyway, should probably change that, but that's okay. It's good to see a couple examples that are kind of weird. So last one, number 4. So we're given that this chunk right here is 4, and this chunk right here is 11. So using those together, I can get that this diagonal is 11 plus 4, which is 15. I then remember that my shorter diagonal is bisected, so if this is 6, then this is 6, making this diagonal 6 plus 6, which is 12. So I've now found my diagonals, so I can now plug into my formula. 1/2 diagonal 1 times diagonal 2. So 1/2 of 12 times 15. And so our area is 90 meters squared. Okay, so those are our notes for today. Head on over to Canvas and go work on your practice. There's also an extra practice review that should be passed out today, so make sure you get that. It has a front and a back, if I remember correctly. And I'll see you guys tomorrow.